All right. So it is the 7th of August, 2024, and we're just having a meeting to talk about sort of some architecture plans and general kind of like division of labors and the organizations of the main software with the sub-Skelly repositories and things like that. Talking about these items which live in the notes folder of the FreeMoCap Foundation repository. So that's github.com/FreeMoCap Foundation in notes, and kind of disorganized, but everything tagged with the current date is the relevant bit. So basically I started with this kind of like, just scrapping on paper, and then I tried to clean it up a little bit with this draw.io board, which the raw version of which is in the folder somewhere. But basically, so we're thinking in the direction of kind of what we're starting to call FreeMoCap 2.0, which is kind of like a cleaned up version of the current architectures. And the main architecture of the FreeMoCap software is that there's sort of like a core software repository, like a core like primary GUI, which is the FreeMoCap/FreeMoCap repo. And the functionality of that sort of primary core software is comprised of the sort of combined capacities of all these sort of sub repos, like sub-Skelly repos. SkellyCam is the sort of star of the show for the most part, but there's others. And the plans going forward is to kind of like clean up some of that, like the poly repo format there, to sort of like clean up, operationalize a lot of it, sort of get more clear about the division of labor and the responsibilities and the relationship between the different subcategories. And eventually, and that's what I talked to Philip about previously, of like sort of have each of the sub-Skellies sort of follow a specified structure where like each one should be able to kind of have like a standalone mode, in addition to being sort of pulled into the main like Voltron machine, and sort of run as a part of the main FreeMoCap thing. So more to talk about there, but for now I just want to talk about the basic layout, and I do it kind of more in the context of this. Kind of, it's sort of conceptually like loosely related to the idea of like the processing pipeline, but it's sort of not fully related to that. There's some complexity there, but I think it's still helpful to think about it. Where on the left you have like the start of the process, the place where the empirical data comes in, and that's handled by SkellyCam. SkellyCam's job is to connect to cameras and or load from videos, which obviously different in many ways, but also quite similar in many others. But it sort of generally handles the ideas like SkellyCam's job is to handle cameras sort of / videos. Its sort of basic capacities are things like viewing the cameras, stop recording, connect to cameras, load videos, sync videos, which would involve which is currently handled by the Skelly synchronized subrepo, but I think we should probably pull that in. And I think that would be SkellyCam, but I could hear arguments that it might want to go in a different place, or an argument that it should remain standalone, but sort of whatever. And then it should also handle like, extracting or sending camera configs, and there's a WebSocket, and there's a kind of a whole conversation on how we want to define like the API of each of these things. So the formatting of like the list here, sort of different for each repo, but that's fine. But anyways, so SkellyCam mostly will be spitting out multi-frame objects, where a multi-frame is basically, if you're imagining this sort of running in like a real-time type of mode, it would be one object / dictionary-like object of images per camera, along with timestamps and metadata and things like that. So again, in a real-time mode, SkellyCam's main job is to spit out those multi-frames at a cadence that matches the frame rate of the cameras or something like that. And in a non-real-time mode, sort of think about things comparably, whatever. Those images, basically raw images, or compressed for front end or raw for processing or saving, whatever, can go mostly into Skelly Tracker. And Skelly Tracker's main job is to do image analysis and computer vision. Like sort of it handles the we've got the sort of the inheritance, the base tracker, the multiple trackers, and all that kind of stuff. But mostly its job is to process images and pull out usually two-dimensional data. And I think in our world, even when we are producing 3D data from 2D data, that's still kind of it's basically just dummying the 3D aspect by just like saying the depth is 1 or whatever. So Skelly Tracker's main job is to produce 2D data. And that 2D data kind of splits. There's sort of this other, like this is a non-existent sub-Skelly right now, like Skelly Calibrate. Like currently we just use AnyPose for that, but I think we're probably going to start evolving beyond that in various ways. But whatever that winds up looking like, it is still going to be pulling in data from Skelly Tracker, and mostly in the form of like the Charuco data and stuff like that. In addition to that, it's also going to be spitting out. Skelly Tracker also produces like skeleton, like sort of the raw tracker skeleton data, like media pipe, etc. And that's going to go mostly into Skelly Forge, so in terms of like the development of these sub like Skelly Cam has gotten by far the most attention. Skelly Tracker is sort of second most identified. Skelly Forge is in there. It's doing a lot of it's doing the jobs well, but I would say its identity is a little bit more like undefined at the moment. So there's sort of some of the earlier stuff is sort of more descriptive, and sort of the right side of this is a little bit more like prescriptive and open for interpretation and discussion. But I think so. Skelly Forge main job, I think, should be basically creating the 3D data like that we use. Question marks around whether it should handle the triangulation or if that should be part of Skelly Calibrate, whatever. A Skelly Calibrate, its output is camera calibration info, which means lens intrinsics, and which is like the basically undistortion in numbers, and then camera extrinsics, which is 6-degree of freedom position, which is a XYZ position and an XYZ rotation. So Skelly Calibrate's main job is to calibrate the cameras and create the capture volume. So Skelly Forge, then, its job is to possibly triangulate, but it could be argued that would go elsewhere. Doesn't super matter. But it also handles things like cleaning and post-processing, which is like gap filling and Butterworth filtering and stuff like that. That's the kind of just like generic data processing side of it. Like it's sort of like, data now, what's the word? Like it's like signal processing, like without any context of what it means. It's just like, oh, these are squiggles, we need to clean them up. And then it would also handle like the conversion and creation of like basically what Aaron's like skeleton model, and it could handle things like tracked point to key point mapping, which is something that came out of my more recent Blender rabbit hole, where the idea would be that like, your media pipes, your OpenPose, your whatever, they produce tracked point data, which is mostly what's going to come out of Skelly Tracker. And then Skelly Forge could have like the mapping object that says, oh, here's how we map these tracked points from whichever tracker we care about into these standardized key points, which we have defined relative to this skeleton. So conversation to be had there, but we can sort of talk about that. And then Skelly Forge would also handle things like center of mass, and then rigid body corrections and things like that. And then I also put these here in green. Like these are things that are sort of more animation focused. So like foot locking, where you like pin the foot to the ground. Something that you would want for an animator, but you could argue is sort of like a little bit too aggressive on the data manipulation to be good for science, but that kind of depends on the application. Face shape keys, there's all this stuff happening there with the, Philip and Andres. There's like a whole, if you guys haven't noticed, there's like a whole little subculture in the public server forming around like figuring out how to process face data, which is super cool and fun. And shape keys, face shape keys is sort of like a animation-y thing that I wasn't even aware about, but it sort of it's a very different way of thinking about mocap data than I would. So it feels more animated, but it's also things like the finger cleanup and some joint angle cleanups. Like you can look at like the like oh like the here's the reasonable anatomical limits of joints. Let's clean up the data that way. Basically, these stuff in the green is sort of Skelly Forgish things that are potentially more animated than scientific, but there's going to be some gradient there based off application. Um, and that's sort of also going to. Oh, I could have changed the picture here, but um, yeah, on this side. So Skelly Forge kind of produces this skeleton data, 3D data, cleaned up, process, post process, whatever you want to say. And this guy here is basically like the main, like sort of like polished output, not raw output, but sort of polished output. And then that could feed into Skelly Blender, which would be that Blender output, the Blender add-on, whose main job is to produce a blend scene and then produce all the animation file types. And then this would have like its own Blender add-on associated with it, which is sort of a lot of Andres' stuff that kind of has, more bells and whistles and controls and like, checkboxes and sort of like the kinds of controls and interface that an animator would want. But sort of the idea is that, this is kind of a terminus of our pipeline. Like it's sort of like, we're going to give you the add-on, we're going to give you some control over that, but it's kind of like, that's sort of beyond, we don't really like worry too much about what happens after that. That's kind of like outside of our scope. There's also this, this is another non-existent one. This is sort of Skelly metrics, again, based off some stuff Aaron's been doing. And the idea would be that the job here to kind of handle like analysis, like stats, static report, or like more like research-based kind of questions. Things like Skelly Forge, that's just sort of part of the base activity of doing motion capture. Skelly metrics would kind of be like, okay, now I want to know more specific things that are sort of relevant to some domain of inquiry. So I might do that sort of calculation there and producing like, statistics and static reports and, whatever. It's sort of, again, this doesn't exist yet, just kind of imagining it. And then Skelly Viewer is going to be our sort of visualization tool that will handle like visualizing 3D, 2D, time series data, and images, which kind of, this is another kind of break from tradition where I think we actually are going to, so right now Skelly Cam, like the existing operating one, holds its own GUI for viewing the data. And I think when we had talked about the independent role of each sub-Skelly, possibly within this same recording, I was talking about it in the context of like each sub-Skelly would like hold its own UI, which it might to some extent, but we might also just let Skelly Viewer do that job. So like, for example, like viewing images and stuff like that, we could build that independently into SkellyCam, but we could also have SkellyCam just use Skelly Viewer for its visualizations. And I realized that sort of like while I was doing that this morning, that, we've had a lot of conversations around like being wary about like circular imports and circular dependencies. We got to like, where are we going to put this, that, and the other? And I realized that if you just think that each of these sub-Skellys can either have the existence of like living together, like sort of being pulled together into like the main FreeMoCap core and sort of operating that way, that's fine. And you could also imagine them operating in a standalone mode, where they are the main store of the show, and then in that mode they could pull in from the sub-Skellys on their own and just construct whatever they need to operate in standalone mode. And that would not have to be a circular import as long as that's managed properly. So like SkellyCam can depend on Skelly Viewer in order to run in a full standalone mode, but it can also just as easily not have a front end and just attach its API to like the core API and then live happily there. So that's kind of the main ideas. Like, Skelly Cam handles images. Skelly Tracker, takes in either videos or connects to cameras and produces multi-frames, which are synchronized images. Skelly Tracker does image analysis and computer vision on those images and produces usually 2D data, for example, Charuco data, media pipe tracks, OpenPose tracks, like just 2D data in general. Calibration relevant information. So I'm saying Charuco, but in the future, I'm hoping to sort of move away from the dependency on Charuco boards, but still just, that it would still be 2D image data that goes into this like calibrate to produce the capture volume calibration and lens intrinsics, camera extrinsics, things like that. Skelly Forge's main job would be to take in 2D data and sort of have a copy of the capture volume definition in order to create 3D data, clean it, post-process it, shove it into our sort of preferred like data model output, and then make that data available for Skelly Viewer, spit it over into Skelly Blender to produce animators. Yeah, Skelly Blender produces blend files and animation-y output data types, and handles things like retargeting and sort of reorganization and for things like Unity or Unreal or whatever. Like that can kind of be Skelly Blender's job. Like put it in the animation space, and then we can do animation stuff with it. And then that data can also go into Skelly Metrics if you want to do more like analysis, like scientific types of analysis. I think a lot of the playground code that Aaron has of like, oh, here's just a million little analyses you can do on the types of data, like that might want to live in Skelly Metrics. And then there actually should be an arrow kind of pointing back from Skelly Metrics into Skelly Viewer. So Skelly Viewer's job is then to just visualize the data in its various formats. Sort of will have like the default visual output and also have it ideally be kind of like composable and configurable for people who want to make their own types of visualizations. And then sort of Skelly Viewer also just, I think, could generally have like a back propagation-y kind of like a role in everybody, where Skelly Viewer's job is sort of collectively to handle things like observability, like of all these things, for like, its main life is to sort of represent a recording, but it also could live happily and sort of using these features as just a way to manage like observability and visualization and sort of bug keeping and whatnot for each of the different sub skellies. Yeah, okay. How long was that? Yeah, 17 minutes. That's not bad. So before I cut the recording, is there anything that you think needs to be said for clarity purposes? Did that make sense? Was it? Anybody willing to speak on camera?
That all makes sense. The only major thing that I didn't see in here is dealing with the saving and exporting and splitting of our data files.
Mm.
Um, and mostly the reason I bring that up is I think like Philip and I have been seeing the signs recently of how that's going to become a bit of a pain the more trackers we put
Mm-hmm.
in, also
Yeah.
as we put in like multi-person tracking and stuff,
Yeah.
where like
Yeah.
what we want to save will heavily depend on everything that's coming out.
Mm-hmm.
And so, and also on that point, something Philip had pointed out before, and something I've seen in Skelly Forge as it exists right now, is that using it on its own is only so useful because
Mm-hmm.
at the end of it, we just end up with this data that we can't like split and export into the current FreeMoCap format.
Uh.
So, meaning like we end up with like if I run Skelly Forge on its own, I'll
Mm-hmm.
get like the post processed NumPy data array,
Mm-hmm.
but not the like here it is hands face NumPy with CSVs and stuff because
Yeah.
that
But
functionality is just in FreeMoCap.
yeah, yeah. So
Um,
that's kind of like that's the past. So we're gonna, like, the future is gonna look a little bit different. But I think that each of these things is, I didn't have it on here, but I have in previous iterations, like sort of each of these stages is going to have its own sort of form of persistence, like things it's going to save to disk. So Skelly Cam will save videos. Skelly Tracker will save the 2D data in various formats. Skelly Forge will save the 3D data in various formats. Skelly Calibrate will save the calibration. Skelly Metrics will save reports. Skelly Viewer will probably save videos, and Skelly Blender will save blend files and other animation formats. So it's gonna have to be, and I think the question of like, yeah, like a lot. I think a lot of the growing pains you're describing are sort of, they are features of the 1.0 kind of like logjam, where there was this kind of like this idea of like there's a more central singular pipeline that produces a standard output, and we're just kind of we're outgrowing that as we sort of make things more generic. So I think so we will want to be sort of mindful of how we save those things out, because I think there is going to need to be some like we're going to need to retain like the concept of like a recording and like the data like sort of that is proliferatively associated with processing the data from a recording, because in the end it's going to be like raw data remains videos sort of like asterisk plus calibration equals raw data, and then all the different 2D data, 3D data, animation data, metric data, visualization data is going to sort of be derived from that. And I think it's going to want to be some sort of databasey central sort of JSON core sort of format that kind of keeps track of each of the data types, 2D data, 3D data, etc. And rather than just saying like, oh, here's the body data, it might just be like there's kind of like a key value listing of, we have the 2D data. Oh, there's like 3 entries in that list. There's media pipe data, there's OpenPose data, there's some other generic thing. Okay, cool. The 3D data, yeah, we there's this many keys on that list, and each of the keys represents like a processing run, and the pipeline definition is part of the metadata or something like that. And then as we get down to like the metrics or like the earth plate for the viewer, we'll need to have an interface where the people can kind of like see what they have available and sort of select. It's like, oh, I want this 2D data to feed into that pipeline, then produce this kind of thing, and then have views based off of that. So that's complex. It's definitely future looking. But I think it's not too hard for me to imagine that. It is just kind of like there would have to be a fair amount of like machinery built around that idea. Because I think right now our system is pretty good at sort of saying like we understand that there is like the staged pipeline, and each stage sort of produces its own type of data. It's just that our current method assumes that there's only like one instance of like the 2D tracking step produces 2D tracking data. And we're just going to need to have like a more sort of complex model there where there is still this like sort of staged-ish data types that gets produced. But the ways that we interact with like downstream data, like 3D data, which relies on 2D data, like the way that we handle those processes is just going to have to be able to sort of like pick from available options. And the way that we like save and manage like individual recordings is going to have to include that sort of concept that there could be different, like multiple instances, probably at least, somewhat overlapping versions of each thing. Because like, well, I guess not, because yeah, I'm thinking like media pipe tracked data versus YOLO cropping plus media pipe tracking data. Like, it's like these are like the configurations could be overlapping even if the data is kind of independent. And it's the kind of thing like it's a challenge that we'll have to think about, but it doesn't seem like one we can't handle. It's just kind of like there's going to be a little bit of like figuring it out as we go along on the basis of like lessons learned. And I think the bottlenecks that you're encountering of like, oh, this is getting really cumbersome to deal with, that's where like you can kind of think about like what would be an idealized version of this, what could work, and then we kind of like test and try things out based on that. Does that make sense?
Yep.
Cool. Anybody else? Well, I'm going to turn off the recording now. If you're watching this in the future, hi. I hope you enjoyed it. And goodbye.